So let's continue our discussion on force and motion, wherein we take a look at how force affects the motion of an object. In this video, we take a look at the kinds of forces that you are likely to encounter in your study of basic physics, particularly as far as our course is concerned. Aside from applied force applied by one object on another object, there are different kinds of forces that you will encounter in your study of basic physics. And before we talk about how to analyze the forces applied on an object and how the object will behave according to the forces that are applied on the object, let's first discuss the different kinds of forces that you will likely encounter in our course. First, there is the weight variable, capital W. Weight is the force applied by Earth's gravity on an object, and we use Newton's second law of motion to give us the equation for weight. The vector weight is just equal to mg, mass of the object, times acceleration due to gravity. And since acceleration due to gravity will depend upon the location of the object, it is different for different locations of the object. For locations on or near the surface of the Earth, again, this will be the default situation for most of the problems and objects that you will encounter in our course. For locations on or near the surface of the Earth, the acceleration due to gravity is given by vector g is equal to negative 9.8 meters per second squared, or negative g, where g is the magnitude of acceleration due to gravity, and the vector g is constant for locations on or near the surface of the Earth. So the weight of an object is constant because both mass and acceleration due to gravity are constant. And note that g is, as far as our course is concerned again, g is negative, g is heading towards the ground or towards negative y direction. That means the weight of the object is always heading vertically downwards, heading towards the ground, or heading towards the negative y direction. As long as you know the mass of the object, you know the weight of the object, and vice versa. If you know the weight of the object, you know the mass of the object. Because W is just equal to mg. For now, next we have the normal force variable, capital N. When an object presses against a surface, say you have an object placed on top of a platform, because of the weight of the object is pressing into the surface. The surface will react by producing a normal force. The surface will react by applying normal force on the object to prevent the object from passing through. The normal force is always perpendicular with respect to the surface upon which the object is pressing into. So if the surface is horizontal, perpendicular to horizontal is vertical, the normal force is vertical. And it is always outward the surface so as to prevent the object from passing through. You can think of it as the surface pushing the object away to prevent it from passing through the surface. So it's always perpendicular with respect to the surface. So much so that if the surface is diagonal, the normal force will also be diagonal in the orientation that it is perpendicular to the diagonal surface. There is no set equation for the normal force. Each situation has its own equation for the normal force. To get the equation for the normal force, you'll have to perform force analysis on the object or system. Next, we have friction. There are two types of friction. You have the sliding friction, friction associated with sliding motion, and you have rolling friction, friction associated with rolling motion. As far as this topic is concerned, as far as our course is concerned, when we say friction, we are talking about sliding friction, friction that opposes sliding motion. Again, friction, small f, vector small f, is sliding friction, friction that opposes sliding motion. So when we say oppose, if the sliding motion is to the left, friction will be in the opposite direction to the right because friction again opposes the motion. So if the motion is to the right, friction will be to the left, opposite direction, and so on. There are two types of sliding friction. We have what is referred to as static friction, F sub S, and kinetic friction, F sub K. Static friction arises to oppose impending motion. You have an object placed on a surface. So placed on a surface, if say you push this object to the left, the object is still at rest. It's just going to start moving. There is impending motion heading to the left. Friction will arise, static friction will arise to oppose that impending motion. Static friction will try to prevent the motion from happening. So F sub S is always opposite the impending motion. So the direction is always opposite the impending motion. For the magnitude of static friction ranges from 0 to a maximum value. The maximum value of the magnitude of static friction is given by mu s n, where mu s is coefficient of static friction, property of the surfaces, the surface pair involved. So each surface pair, each type of pairing of surfaces will have its own value of coefficient of static friction. For flat surfaces, again, for flat surfaces, the range of mu s is from 0 to 1. Okay, again, from 0 to 1. For jagged surfaces, mu s may be greater than 1. Note that mu s is, whether you have flat surface or jagged surface, mu s is never less than 0. There is no such thing as negative coefficient of static friction. So if later on you calculate mu s that is negative, you made a mistake somewhere in your analysis because mu s is always positive. For flat surfaces, it ranges from 0 to 1. For jagged surfaces, mu s may be greater than 1. Also note that mu s does not have a unit. It is a unitless quantity. And N, capital N, is the normal force magnitude. So look at the situation provided by the problem, perform force analysis, and determine the magnitude of the normal force. That normal force magnitude, that's what you will use for capital N in the equation for friction. So static friction has a maximum value. If this maximum value is exceeded, meaning the impending motion is greater than mu s, and static friction is unable to stop the motion from happening, and the object will begin to slide. When the object is already sliding, there's already existing sliding motion. The friction that will oppose that sliding motion is kinetic friction. You have F sub k arising to oppose existing sliding motion. So again, the direction of the friction, of kinetic friction in this case, is always opposite that of the motion of the object. So if the motion is heading to the left, kinetic friction is heading to the right, opposite direction. If the motion is heading to the right, kinetic friction will be heading to the left. So always opposite the motion, because friction opposes existing motion. It wants to slow down the sliding motion and make the object come to a stop. The magnitude of kinetic friction, F sub k, is constant, unlike static friction, which ranges from 0 to a maximum value. Kinetic friction magnitude is constant at mu k n. Mu k is coefficient of kinetic friction. And again, capital N is normal force magnitude. For flat surfaces, mu k typically ranges from 0 to 1. Again, just like mu s, mu k is unitless, does not have a unit, and it is never less than 0. You don't have negative coefficient of kinetic friction. So for flat surfaces, it ranges from 0 to 1. For jagged surfaces, mu k may be greater than 1. Lastly, we have tension, capital T. When an object is stretched, it reacts by applying tension, pulling at objects attached to its ends. While any object may experience and apply tension, tension is particularly applicable for strings, wires, cables, ropes, and so on. For example, you have a rope attached to, say, the ceiling, and an object is suspended from the rope. Because of the weight of the object, the rope is being stretched. The rope will react by producing tension. At its ends, it will pull with tension T. So at this end, it will pull on the ceiling downwards with tension T. And at the other end, wherein the object is tied to and suspended, it will pull upward with a tension T. Okay, the orientation of the force tension is always parallel with the orientation of the string, rope, or wire, and so on. So you have applied force, weight, normal force, friction, static friction, and kinetic friction, and you have tension. These are the more common types of forces that you are likely to encounter in your study of basic physics, particularly in this course. So that's it for now. In the next video, we'll cover equilibrium condition. And then from there, we'll take a look at force analysis, how to analyze the forces applied on the system. So again, that's it for now. Thank you for watching.